All right, let's go ahead and look at our Doona for today. So we're saying that we're given an inequality, 4 is less than 12, and we decide to subtract x from both sides. We're told if x is a positive number, the inequality is preserved, reversed, or there's not enough information to tell. So looking at this, and we think back to some of the work that we did yesterday, as we explored this particular concept, we basically came up with 3 general rules about whether it was going to be preserved or reversed. If we remember correctly, when we explored it, any additions or subtractions, it didn't matter what the value was, were going to be where they were preserved. So here we see we're subtracting x from both sides. It doesn't matter what x is. This fact that x is a positive number, that's actually more information than we need. So we know for this particular one that it is going to be preserved. Coming down here, we see that given the inequality, 3 is greater than -2. We decide to add x to both sides. So when we add x to both sides, again, it doesn't matter whether x is positive or negative. So we don't really need to know anything about x. We know that it's going to be preserved. As we look over here at the third one, we're now given the inequality 4 is less than 12, and we're told that we are going to multiply x to both sides. Sorry, mine's a little bit messed up. Multiply x to both sides, so it's 4 times x and 12 times x. We're told x is a negative number. The inequality is preserved or reversed. So thinking about this one, we had different rules for multiplications and division. So for multiplication and division, we actually had 2 rules. One was that if it was a positive multiplication, that it was going to be preserved, and if it was a negative multiplication, then it was going to be reversed. And this comes from the idea that when you multiply by a negative, you're actually flipping the sign, because if you have a negative already and you multiply by a negative, it becomes positive. If you have a positive already and you multiply by a negative, it becomes negative. And so that reverses the value of what that particular one is, and thus reverses the value of that. So here we see we have multiplication of a negative number. We don't need to know anything more about that negative number except that it is negative, and so we know that it is going to be reversed. Finally, we're given the inequality 3 is greater than -2. We decide to multiply x to both sides. The inequality is preserved or reversed. Now here we're talking about a multiplication. If we're talking about a multiplication, we have to know whether it's positive or negative multiplication, or even if it's 0, because we saw yesterday if we multiply both sides by 0, that would even make them equal. So that would also kind of reverse or in some other way change our inequality in our equation in that case. So looking at this, we don't have enough information here because we don't know whether it's positive or negative. If x was a positive number, it would be preserved. If x was a negative number, it would be reversed. If x was 0, then it would actually become an equation. So here we look at this, there's actually not enough information to tell. All right, let's flip on over and look at our aim for today. All right, today's aim, Kipsters will be able to write and solve inequalities. So here's the big start to what we've been working on as we go through. We're going to look at this. All right, we have Tariq is trying to save $265 to buy a new tablet. Right now he has $40 and can save $38 a week. Write and evaluate an expression to represent the amount of money saved after 2 weeks. All right, so if we're thinking about this particular problem, we just want to ground ourselves in why we would be thinking about this in regard to inequalities. So with inequalities, we're saying something is greater than something else or less than something else. And so at this point, if he wants to be able to buy that tablet, we have to ask ourselves the question, does he have to have exactly $265.49? Or could he have more than that? All right, so we're looking for a time when he's going to have at least $265.49. So we're looking for some amount of time when he has greater than or equal to $265.49. Because it's not saying that he has to buy it when he has exactly $265.49. Not to mention, if he's getting allowance in $38 per week, he's never going to get exactly $265.49 because they're coming in chunks of $38. So let's look through. We're going to write and evaluate an expression to represent the amount of money saved after certain amounts of time. So looking at 2 weeks, how much money would he have after 2 weeks? Write an expression to represent that. So obviously, you should have written down that he has $40 plus an additional $38 for every week that has passed. In this particular case, that's $40 plus, $38 plus $38. In this case, we're talking about 2 weeks. As we go ahead and solve that one, we have 40 plus 76, which is going to be $116. Does he have enough money? No. So at this point, this is less than 265, and we know that we need it to be greater than or equal to $265.49. Well, now let's go through, let's use the same expression and find how much money he would have after these number of weeks. Go ahead and do that on your own. Go ahead and pause the video, and once you've got all those expressions solved, go ahead and pick back up. All right, so double check all of your expressions and your results. So when we're looking through this, the next question that we really have to ask ourselves is, all right, now to answer this question, which of these values, when is he going to have enough money in order to actually pay for his tablet? Well, there's more than one answer here. We're looking for any value that's greater than $265.49. So we can see if he waits 6 weeks, he'll have enough money. 7 weeks, he'll have enough money. 8 weeks, he'll have enough money. So to answer this question down here, when will Tariq have enough money to buy the tablet? Well, he'll have enough money to buy the tablet 6 weeks or later. 6 weeks or later. So anytime after 6 weeks, he'll be able to purchase that tablet. Now, again, when we think about this, we're looking for things that are greater than or equal to $265.49, and that's really important when we come over and we start looking at our next piece is we're not looking for a specific time, we're looking for any amount of time, and this is why we're going to write this as an inequality where he will have enough money. So we want to write an inequality that will generalize this problem. So thinking about it, we need an inequality symbol. We know how much money he makes each week. So we have 38 times W plus the $40 he already has. Now, this is the amount of money that he's going to have at any given number of weeks. And so we've already calculated that quite a number of times, and the point is not really to be able to do that. But we know that that value that he has at that given amount of time needs to be what? So you're thinking to yourself well, it needs to be bigger than $265.95. Because that is the price of the tablet. If he has exactly that amount of money, then he'll be good to go. If he has less than that amount of money, that's not going to be good. If he has greater than that amount of money, then he'll be good. So we're thinking to ourselves once again, when will this value, which is the amount of money that he has, be greater than or equal to the amount of money that he needs? All right, so let's look over here and let's look at something a little bit different. It says the sum of two consecutive odd integers. Okay, so remember when we're talking about consecutive odd integers, we've kind of had this conversation before. These are two integers that are consecutive and odd. So 1 and 3, or 3 and 5, or 21 and 23. The sum of them is greater than -12. So do me a favor right now, write pairs of consecutive odd integers that would make this true. And I want you to do it in terms of an inequality. So for example, you might write -5 and plus -3, and that's going to be greater than -12, and then just prove it to me. -8 is greater than -12. Give me 3 more examples. All right, so looking at your examples, the one example that I want to talk about, whether you wrote this one down on your page or not, would be -7 plus -5. Think to yourself, is this one going to meet the criteria? All right, so what we see here is this is our borderline example. This is what I kind of think about as our starting point. Last year when you talked about graphing inequalities, you would either have an open circle or a closed circle, depending on whether that starting value was part of the inequality or not. And this is that starting value right here, and we have to determine whether it's part of the inequality or not. So we have -12 is greater than -12. Is -12 greater than -12? No, it's not. It's equal to. And so this inequality symbol, because it's just more than, does not have an or equal to portion to it. So that's why this particular solution would not work. That is not a workable solution, because although it's very, very, very close, and anything else that would be greater than that would work, this one does not work. So any number that you started with above -7, so -5, -3, -1, 1, 2, or 1, 3, 5, 7, 9, and so on would work for this particular expression. So hopefully you've got that down on your paper. Now we want to generalize this, okay? We want to know what the smallest value is that will make this true. So we're going to write an inequality to sort this out. Now, there's a couple things to think about here when we're writing this inequality, is we have to make sure that it's an odd integer. So one way to set this up is just to be thinking about this as like, well, we have an integer, x, and we need it to be an odd integer. So really, when we think about this, the only way we can ensure that a value is going to be odd is if we multiply it by 2, because that will guarantee that it will be even. We multiply it by 2 and then add 1. So if we guarantee something is even, then we have to add 1 to it. That will guarantee that it's odd. So if we want the next odd integer, what do I need to do? So thinking about this, we have, say I have the number 3. How do I get to the next odd integer? All right, you need to add 2 to it. So I'm going to take the odd integer that I have, 2x plus 1, and I'm going to add 2 more. Those are my 2 odd integers. So we need the sum of the 2 odd integers, so that would be these 2 here, to be more than -12. So looking at this, more than 12, which inequality symbol are we thinking about here? More than 12 would be greater than 12. So our inequality here is going to be 2x plus 1, and because we're summing our 2 integers here, odd integer 1 and odd integer 2, plus 2x plus 1 plus 2 is going to be greater than -12. Now, we definitely want to simplify this, and we simplify this just like we simplify an equation. So let's go ahead and take this side and combine our like terms. Go ahead and do that now. So when we combine our like terms, we should get 4x plus 4 is greater than -12. So the most important thing that I think moving into today's work that's different than equations is focusing in on this inequality symbol, making sure we're not losing that inequality symbol or at any point reversing that inequality symbol unless we need to, right? Notice the unless we need to there. That's something we definitely need to be thinking about. We talked about yesterday reasons we would need to reverse an inequality symbol, and that's if we multiply or divide both sides by a negative. So in this particular problem, we're going to do some inverse operations. We're going to be doing things to both sides of the equation. If one of those inverse operations is multiplying or dividing both sides by a negative, then we know we have to reverse the inequality symbol. All right, so solve the inequality written in part A. So we're down here looking at solving the inequality. 4x plus 4 is greater than negative 12. This is our inequality. So solve it just like it's an equation, because if we do the same thing to both sides, it's going to keep the inequality statement true. So looking at this, we have 4x plus 4 plus negative 4 is greater than negative 12 plus negative 4. That adds up to 0, leaving me with 4x is greater than negative 16. Now I want to think about that operation really quickly. I added negative 4 to both sides. If I add negative 4 to both sides, does that preserve the inequality or reverse the inequality? Good. Adding anything, subtracting anything preserves the inequality. So you'll notice that I've left the inequality symbol the same. All right, now I need to divide both sides by 4. That's going to give me x and negative 4. And before I write down the inequality, I want to think to myself, well, I just divided both sides by 4. Is division of a positive number something that preserves or reverses the inequality? Again, going back to our lesson from yesterday, a positive division will preserve the inequality. So I'm going to keep my inequality the same. All right, so it tells me x is greater than negative 4. All right, so when we go back to our solution up here, and we look at this, we're like, oh, well, we said that we needed something that was an odd integer. Negative 4 is definitely not an odd integer. If we go back to figure out what our actual solution and answer to this question is, our odd integer is 2 times x plus 1. So coming back over here, x is greater than negative 4, so 2 times negative 4 plus 1 is going to be negative 8 plus 1 is negative 7. That goes back to that idea all the way up here that we found out that anything that was greater than negative 7 was going to be working. All right? So those are a couple of models about how we can use inequalities. We're going to flip on over to the other side, and we're going to give you a little bit of chance to practice on that. Okay, so this is a word problem. The first thing asks you to write an inequality, represent the total spent, where R is the number of tickets purchased. So we're looking at this, and we need to think through the situation. Is this a situation where I need more than something, less than something, equal to something? Obviously, it's going to be an inequality because it's asking for an inequality. So we're looking for greater than something or less than something. All right, so when we look at this, it says he wanted to spend the rest of his money on ride tickets. So I guess we're trying to figure out how many ride tickets he can purchase. So I'm thinking about where my inequality lies here. And so thinking about this, let's go ahead and try on your own to write an inequality, and then we'll check in on it before you move on and solve the rest of it. All right, so thinking about this scenario, we're talking about the amount of money that he has to spend. So he has already spent, so we have $3.75, and he's going to be spending an additional $1.25 on each ride. So $101.25 per ride. Now, I need to be thinking about he has $22.50 in his pocket. Does this value need to be less than this or greater than this? So if we're thinking about it, this is money that he has to spend. He can't spend more than how much money he has. It has to be less than how much money he has. So this is where we need to make sure that our inequality is set up right. So coming down to the next one, it's asking us to use this inequality to determine if you can purchase 10 tickets. So tickets is our R. So we're being told that R is equal to 10. We're going to see if that makes the inequality true. So all we're doing here is you're being asked to plug in R is equal to 10 and find out what the value is. So go ahead and plug in R is equal to 10 to find out what the value is. You should be setting this up kind of in a very organized fashion. In order to go ahead and solve this. And so I should see the steps one by one coming down the line. So hopefully your first step here was to go ahead and do this multiplication. Multiplying by 10 is super easy. It actually just moves the decimal once to the right. So this is going to be $3.75 plus $12.50. Is less than $22.50. Then we need to add that amount of money together. So $12.50 plus $3.75. And that's going to give me $16.25. Is less than $22.50. And so this is where we stop. To figure out whether he has enough money. Is the inequality statement true? Well, absolutely, this is true. $16.25 is less than. So, yes, he will have enough money. All right. And so if we want the total number of maximum tickets that he can buy based on this, that means we actually need to solve the inequality. So go ahead and take the inequality. We're going to write it back down. $3.75 plus $1.25 times R is less than $22.50. As you go through, again, be thinking about when you're doing your inverse operations, is this an inverse operation that's going to preserve or reverse the inequality? So go ahead and solve this. And then check back in. All right, so this is the value that we have. And when I look at this, there's one thing that I think about kind of as I'm coming down here at the end when I look at my inequality, and I'm wondering, can he spend exactly $22.50? Is that something that's okay, or does he have to have something left over in his pocket? So he can spend exactly $22.50. So when we go back to this, the amount he spends can be less than or equal to $22.50. So I need to go ahead and go through and add that into my inequality. Because this is when we come down to our answer is like he can buy exactly 15 tickets. That would be okay. All right. So the number of tickets that he can buy has to be less than or equal to 15. So the largest thing that he could purchase is going to be exactly 15 tickets. All right. So he can purchase 15 tickets. All right, and the last problem that you have for today, it says, write and solve an inequality statement that the following below. On a particular airline, checked bags can weigh no more than 50 pounds. Sally packed 32 pounds of clothes and 5 identical gifts in suitcases that weigh 8 pounds. Write an inequality to represent this situation. Alright, so one thing that I want to clarify before you get started on this one is, because I definitely found this confusing when I first looked at this problem. The suitcase itself weighs 8 pounds. The 5 identical gifts, we don't know how much each of those identical gifts weighs. So each of those weighs X. We're going to make that our variable. The suitcase weighs 8 pounds. Go ahead and take a stab at writing an inequality to represent how much each of the identical gifts can possibly weigh. So when we do this, I want to focus in on here on the no more than 50 pounds, all right? So the question here is, can it weigh 50 pounds? Is 50 pounds okay? And it's no more than. All right, so 50 pounds is okay. So when we write our inequality, we know that it's going to be, do we need it to be less than or greater than 50 pounds? All right, no more than 50 pounds. So it can't be any more than that. It needs to be less than 50 pounds. And then we said it could be 50 pounds. 50 pounds is okay. So something is less than or equal to 50 pounds. Well, what are we adding up here? We have 32 pounds of clothes plus 5 identical gifts. We don't know what those gifts weigh. Plus, we have the 8 pounds of actual suitcase. So hopefully this is the inequality that you have. If not, go ahead and tweak it just a little bit. Go ahead and solve this inequality to find out how much each of those identical gifts can weigh. Hint, you'll have to start by simplifying. And so as we finish up here, we can see that the value has to be less than or equal to 2. Again, as I went through that, I was double checking if there were any of my inverse operations that I did that were going to reverse the inequality symbol, but an addition of negative 40, it's an addition, so that's going to preserve it. We have the division of 5. And that's a division of a positive number, so that's also going to preserve it. So again, we see our inequality symbol comes down and stays the same all the way down. So x is less than or equal to 2. So what we can say here is that the gifts can weigh no more than 2 pounds. So thinking about this just really quickly, what could work? No more than 2 pounds. X is less than or equal to 2 pounds. 1.5 pounds would be good. 1 pound would be good. 1.9999999 pounds would be good. 2 pounds would be good. 2.000001 pounds doesn't cut it. All right, so go ahead and flip on over to your independent work and get that work done for today.